Now we can extend this technique if we're looking for other spots on the scale between 10 and 100. Suppose we wanted to find where 80 belonged. What would we do? Well, we'd find the base 10 log of 80. There it is. It's about 1.90. And we can look, the number for 80 must be this mark here. Is that about a tenth of the way down from 100 and about 9/10 of the way up from 10? Well, that looks about right. We find other numbers. If we were looking for 20, what would we expect? Still a number between 1 and 2, because the log we're looking for is between 10 and 100. But now we're looking for something closer to 1 and farther from 2. If we ask the calculator to give us the precise calculations, what do we get? We get 1.30. And if we look, does it seem that the 20 is about 1/3 of the way up from 10? Well, it looks as though it is. That looks right. Now, what we have here seems to be not this method, although the method I was just describing would work, but it seems to be a more direct use, which is perfectly consistent with the stage of our study when this assignment was due. The technique seems to be to take some powers of 10 and use them to produce explicit points, known points, which wouldn't be the nice whole numbers that we want, not 20, 30, but things in between, as 54, 28 would be in between. And to mark those places and then to estimate by knowing a few numbers, to estimate where the whole numbers that we're interested in would go. And it seems this student, like many others, used a find the square root technique, which is a little bit backwards, a little bit seeing things the wrong way around, but it does allow you to find a midpoint between any two known marks. So that brings up a further question. Suppose you had a good and accurate log scale and you were looking at the scale between 1 and 10, nicely marked as this one is, with the places for the numbers in between. How would you use the log scale to estimate the square root of 10? So we'll leave that question for later in the class.